the way this thing works is now they say, hey, by the way, that image is not available on your local machine because what I'm seeing here is Arun Gupta / reading none and Arun Gupta / reading :from. That's a tag of the image. So what I'm asking is, okay, hey, by the way, Arun Gupta / reading, it looks for latest by default, and if it doesn't find the image, boom, it just downloads it and it runs it. So it's going to take a few seconds to download it, but once it downloads it, then the image is, the container is fired up, and then what we can do is we can take a look at it, what is the experience, because the whole idea is build the image and run it and get the exact same result. Okay. Say again? No, this is Docker Mac. Yeah. Please don't use virtual machine anymore. Yeah. So here, if you look at it, Docker container ls. If I do this, it says, hey, by the way, you're running, and it's got a weird name, Forwin Caldish. And if you don't give it a name, it just picks up a random name. But now, what I can do is, I can still do the same command. Actually, go back here. This is really right? Yeah. So let's do this. Voila, we get the same hello. Okay, the exciting moment. But because getting the same result, that's the whole intent, because now it's Dockerized. Okay, so what I can do is I can say Docker container stop, pick up the container name from here, stop the container, and then remove the container. Otherwise, the port doesn't get freed up. Okay, so that's sort of my experience here. Now, so let's talk about that point of Docker. So what I was using here is, when you see on the top, is Docker for Mac. Now you can download Docker Desktop that comes in both Mac and Windows flavor, or you can install Docker locally in any of the Linux flavors as well. So pretty much your local development happens using that Docker version. Docker, once you're done with that, but for say some reason you're not allowed to install over here, that's when customers fire up an EC2 instance and say, I'm going to use the Docker over there. And that's entirely possible. But the whole idea here is to have that local environment where I can play with it, I can debug it. Now, one thing that I've shown you here, which I was really proud of using Kubernetes, is I fired up my app in Kubernetes now with debug. I'm used to IntelliJ debugging. So how does that work out? So let me fire up IntelliJ. So we'll talk about it. How do I do debugging using IntelliJ here? So all right, now what I've done is I've got the app up and running using Docker. The next thing is to understand sort of my Kubernetes now. So let's talk about Kubernetes for a bit. Now, when you think in terms of Kubernetes, there are two key concepts. One is the control plane. Between how people call it. I like calling this kubectl. But kubectl is what you give a command to the control plane, and then your containers are really running down the data plane. Okay? What do you give to kubectl? You give a manifest file. And the manifest file is where you have, okay, what are the different Kubernetes constructs that need to be created? What are the Kubernetes constructs? Kubernetes doesn't have a concept of a container. It has a concept of a pod. And why pod? Because often you may not want to run a container only. You may want to inject some sidecar containers. So pod is sort of the lowest unit that you can deploy in Kubernetes. So think about it. Data plane, control plane, data plane. You use kubectl to talk to the control plane. Give it a pod manifest file or pod spec, as it's called in Kubernetes language. Okay? So what you can do next is basically fire up a local Kubernetes cluster, and once you fire it up, then you say, okay, go ahead and now take this kubectl, point to the Kubernetes cluster running on my local machine, and issue the command. And that will basically download that Docker image that you did already, and then you run it on the local Kubernetes. Okay. So now, if I look at it, I have this kubectl CLI already installed here. So I'll say kubectl config get context, and I have a few clusters that are already created here. This cluster is old because it is no longer valid. and I have a cluster that I've been playing Minecraft on, so that's there. And then there are other clusters as well. Well, actually, my son created that cluster because he wanted to post Minecraft to his friends. So I made him learn Helm charts and all those things. So he figured out what a Helm chart is, and we deployed it, and he's playing with EBS volumes and all. It's a good way to educate the kids what Kubernetes is. Not such a good way, but oh wait. Anyway, one more thing I want to highlight here is if you look at another way that I've seen a lot of customers doing Kubernetes locally on their machine is if I go to say a Kubernetes tag here. Correct. That's what I was coming. That's exactly what I was coming at. So there are multiple ways by which you can install Kubernetes on your local machine. MiniQ is what creates sort of a local VM on your machine, and that's using VirtualBox or any virtualization provider, and that's what fires up Kubernetes on your local machine. A single node cluster. Typically, your Kubernetes is not a single node cluster; it is a multi-node cluster, but it fires up a single node cluster. Good enough for testing. MiniQ is common. There is when this thing comes up, there's a Docker desktop also has a single node Kubernetes cluster available to you, so you can use that as well. If you go back here, I don't think I have a complete list here. But those are the two popular options that I've seen essentially on how people are doing it. There's a client as well that is becoming more.
Is given an IP address, but that IP address is ephemeral. What that means is, if the pod dies, Kubernetes will make sure that the pod comes back up again, but maybe assign a different IP address. So what that means is that the pod cannot be used as up to the pod using labels. So a pod has a label like a name value pair and service. Now, is that enough? Not really. You need a service, you need a pod. In between, you need something called as a deployment, because deployment will control how many replicas of the pod are going to be there. So think about, for just one microservice, you really need a pod, a deployment, and a service. Think about a typical microservices-based application. You have lots and lots of those, lots of services, lots of deployments, lots of pods. Okay, so managing that using single file becomes very challenging, and that's where concepts like Helm comes in. Helm chart is sort of the de facto way how customers are building or bundling multiple Kubernetes resources together in one directory. Okay, so what I'm doing here is I'm installing the Helm CLI, and I'll show you how the Helm chart for my application looks like. So I will show you first of all the pod spec, the deployment spec, the service spec, and then I'll show you what the Helm chart looks like. Yes, sir. So let's get this right. So correct. So the question is, the relationship between the container and the pod and the image is not very clear, right? So the way this works is your image is published on a registry. Well, let's look at the spec itself. I think that'll add some clarity to it. So I'm going to go back to my app here. I'm going to say show me the deployment spec here. Okay. I'm saying this is an API version. Now each resource in Kubernetes has an API version. This is a deployment spec. Here is a label that I've attached to it. I'm saying this deployment is going to create one replica of the pod, and in this deployment I'm going to specify the selector as well that match any pod that has these labels. When I come down here, this is my pod spec here that also has app code. I mean, this is kind of redundant, but I can specify it just for verbosity. And now in here I'm saying in my pod spec I'm specifying the image name and the ports that I'm going to expose. Okay, so that's sort of my pod spec here. So if I go back here, then there is my greeting service here. In greeting service, I'm saying, now remember, the reason that we need a service is because the IP address given to pod is only temporary. That's what ephemeral means. So if a pod dies, it comes up somewhere else, it's a different IP address. So think of it as a front-end pod and a back-end pod. That means the front-end pod cannot rely upon the IP address of the back-end pod. And that's where service really gives you a logical name. So in this case, for example, I'm saying this is the API version, this is the kind service, not deployment, but I'm giving it a name, greeting service, and I'm saying, oh, pick any parts that have app:greeting label. If you remember from our deployment spec, each pod was given this label, and then I'm specifying some values here that I'm exposing a port 80 where the target port in the container is 8080. I'll talk about this in a second. So the key part here is from your microservice perspective, this will corresponding to one microservice, and this is now available at greeting service name. So there is a DNS scheme over here. So I can say, hey, greeting service.host.cluster name. I can access it like this. And whether it's accessible inside the cluster or outside the cluster is defined by this type attribute here. So if the moment I say type::load balancer, this service is now, when it's deployed on a cloud or a local host, whatever it is exposed accordingly. So for example, if you're doing this on AWS cloud, by default this will be exposed as an ELB. So it's as an elastic load balancer. Very simple, very clean. There are other modes and mechanisms by which you can follow. I won't confuse you with that, but that's sort of the common way. By default, this service is accessible inside the cluster, and that's a cool design because not all the services need to be exposed publicly. They should, as long as they're accessible within the cluster with a logical name. That's the idea. So now I have my deployment spec, my service spec, but I said for each microservice I need them. That's where it becomes challenging, okay? So let's look at sort of the Helm chart here. So Helm chart is nothing but a directory here in this case, okay? So I have a chart.yaml which has the metadata about the chart itself, nothing fancy in here, it just has a name. Then it is a values.yaml where I'm defining certain constants, so to say, that can be used across my different deployment specs. And the whole idea here is, because I'm using a templating language, I can define my common values here and leverage them across my deployment specs here. And then that's where I go into my templates directory. So I have my greeting deployment here. Now the language is a bit cryptic here, at the first glance at least, but here I'm using the templating language. Oh, whatever the release name is from values.yaml, inject it here. Whatever the labels are there, inject it here. Whatever the values, replica count, etc. are here, inject them here. So what the Helm chart gives you is, it gives you an ability by which you can bring some consistency to naming your services. Because you're saying across the board, replicas are going to be 5. Across the board, the names are going to be release name dash whatever. So whatever you're defining it brings that consistency, and it also gives you an ability by which you can deploy all of those artifacts using a single command. So essentially on your local machine, you have Helm CLI install, and you say Helm install, boom, give it the directory name, and that chart gets installed into your Kubernetes cluster. And then what does that mean is, that chart gets installed means it basically takes all those artifacts, these ones particularly, so anything that is in the deployment directory, and it just deploys them one by one. So with a single command you can deploy the entire application and delete the entire application. Okay, that's sort of the basic idea here. So here you can see, for example, I can see what configurations are available for me. I'm setting it to Docker for desktop. and it doesn't seem to be very happy Docker for desktop right now. If you look at the preferences again, this thing is spinning in circles. So we'll see when it comes back. I think it didn't like that I said, you know what, skip this version. It's getting upset. Screw it. Then I install the Helm CLI. Then I check the version. Then I initialize Helm. Then I get to the manifest directory and I say just install the app. And then I can say kubectl get parts, get service, and this is a command by which I can say kubectl get me the greeting. That's remember my app was a chart name, and it picked up the name at that my app dash greeting. It gives it a default name because that's the name we specified in the chart. And then I'm saying, oh, you have a detailed description of the chart, but using this JSON path, give me the host name where the thing is hosted, because remember this is running on an ELB, so it's got a cryptic name in that sense. So now I'm saying curl using that ELB name 8080 hello. That's it. So exact same app, first using Maven, then using Docker, and then using Kubernetes. You should be getting the exact same results. That's sort of your Kubernetes journey to begin with. Now, one of the things that I may not be able to show you because I don't have a Kubernetes cluster running here, but the whole idea is, how do you debug these applications? Very much like a Java application. So essentially in this case, for example, I'm setting up a remote endpoint. I happen to call it Docker, and it tells me what JDK options I need to specify in here. So now what I can do is, if you look at my, say, Docker file here, so if I look at my Docker file, I've specified _Java_ options right here itself. And if I specify that, that's what allows me to attach a remote debugger. So I'm using very standard Java commands, but I can attach a remote debugger now, and boom, tap into the Java file. So for example here, I'm setting up a breakpoint, and I'm connected to the remote address. I call the endpoint, and then I hit the breakpoint, and I can see my entire state of the application. So usual tools are available to debug your application as well. Then the next thing comes to your mind is, all right, cool, I've done playing, now let's get real. I want to take this to the cloud. So what are your options for running Kubernetes cluster on the cloud? More than 50% of Kubernetes runs on AWS. That's the latest CNCF survey. Because it doesn't matter where it was created, where it's sitting right now. What matters is the operational performance of the Kubernetes clusters. Okay, so we got tons of customers who are running Kubernetes at a very crazy scale at AWS. You need those EC2 instances. You need the IOPS. You need the storage. You need all of that capability. You need that availability of not just the service but the compute power across regions. We got lots and lots of customers who are running at a very high scale, running thousands of nodes, in production. So that's where the excitement comes in, and there's the reason. So now, what are the different ways by which you can run Kubernetes on EC2 or AWS? Well, first of all, there is bring your own Kubernetes, where you can say, hey, by the way, I've been using kops or kubeadm or CloudFormation or Terraform, lots of different tools, and I can bring my own Kubernetes and run it on EC2. In which case, remember the control plane and the data plane? We're managing both. Then last year, Amazon EKS, which is our managed Kubernetes service, was GA. That means it's generally available to everybody. With Amazon EKS, we manage the control plane. You bring the data plane and you attach it to the control plane. And that's where I've seen, I was literally visiting a ton of our customers, some top-end customers in India last week, and they all kept saying, it's as if I was feeding the message to them that, hey, Arun, we love Amazon EKS because managing Kubernetes clusters is hard. You have to manage an etcd cluster, you have to manage the master nodes, backup, security, and all those things become nasty. That's not your core competency. That's undifferentiated heavy lifting for you. That's where Amazon EKS helps out with a lot of our customers. They fire up our Amazon EKS cluster, attach a data plane, and bingo. They're ready to build their application and now actually deploy them on the Kubernetes. They want to bear the fruit of Kubernetes without going through the pain of Kubernetes. That's the important part to understand. So now, how do we tell our customers to fire up a Kubernetes cluster? EKS Cuddle is just a kubectl. EKS Cuddle is a CLI that is created by one of our partners, Weaveworks. And that's sort of the way we recommend all our customers to fire up EKS clusters. A lot of them do, actually. So literally, you can say EKS Cuddle create cluster, and it'll create a cluster for you. But it comes with a lot of reasonable defaults. But if you want to override some of those defaults, that's totally all right. So in this case, for example, you're saying EKS Cuddle create cluster, cluster name, number of worker nodes, and in what region. It's got all kind of crazy support. This is not an EKS session, so I won't go into the details for that. But essentially, once the cluster is created, then you can say, show me the nodes. And now, it says there are 4 nodes available over here. And then when you say, give me the list of configurations that are available, it's got Docker for desktop and my cluster created on the US West 2 region as well. So I can switch back and forth, which is indicated by the star, on which configuration is currently active. Okay. Now, you have tested your application on the local machine. Now you want to migrate that application to in the cloud. How do you do this? Well, we have seen where customers... Step back for a second. The data plane is where your worker nodes are, where your containers are running. Okay, but the state of that, now hopefully you're building, ideally you're building stateless applications, not stateful applications. No, well, and that's a reality. That's a reality. You know, and Kubernetes, there are ways by which you can do the stateless, stateful applications. Then you got to understand the migration of those stateful applications in a slightly different way. But majority of the applications that are on Kubernetes are stateless applications. So what customers do is, but what happens is, let's try to understand when I say kubectl create this manifest, what happens? At a very high level, the command really goes to the controller, which is sort of a layer in the master. It says, hey, I want to create this pod. It doesn't create the pod right away. You know, the controller says, okay, you want me to create this pod, I'm going to run this validation, blah, 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 and then I'm going to store the state of what that pod should look like, number of replicas, etc., labels, etc., in etcd, which is a distributed database part of the master itself. Then there are other controllers running in the master itself, which says, oh, I'm watching this etcd registry, and this state is written over here, but I see this pod is not assigned to any worker node. So let me pick up this worker node, and I have an algorithm by which I will figure out where this pod needs to be scheduled. I'm going to schedule the pod. I'm going to tag it that, oh, you are scheduled, not running yet. Finally, you get to the part where another controller wakes up and says, oh, this pod is scheduled but is not running. Let me make it to running. So there is a loop that happens multiple times in the master, which basically makes sure that the pods are running on the data plane. And if you think about it, etcd is a really critical piece of this entire infrastructure. So the entire state of the cluster is stored in etcd. What pods are running, what services, etc. So etcd becomes a very critical piece of it. So now there are 2 ways that we have seen our customers doing the migration from test dev to prod, or whatever way you want to do this. First is where they say, oh, I'm going to take a backup of this etcd cluster and restore it in the new etcd cluster. There are tools by Heptio, which is now acquired by VMware. They wrote a tool called as Arc, and I think it's a new name now, Wario or something like that. But that tool is basically takes a backup of an etcd cluster and restores it. So that's one way that we have seen. Or where the other way that we have seen is where customers use a CI/CD pipeline. That I know exactly what my Helm charts are. I have kubectl config to my local cluster. I'm going to switch the gear to kubectl, do this cluster on the cloud, and rerun my production pipeline. So no harm done, you know, though no backup, no downtime, but essentially you have 2 parallel clusters running, double the cost, 2 parallel clusters running, and then either in the front end or wherever you can just flip the switch that, hey, instead of using this cluster, move to this cluster instead. So that's the way customers do it. So backup restore, or actually just changing kubectl config and run your production line pointing to the right configuration file. And that's what it walks through. So this time, because I'm running in Amazon EKS, so what I get is a pointer to ELB, and then I access my application again. I should get the exact same results called as hello. All right. So that's sort of migrating. Now let's recap the journey for a second. Dockerize, test locally, write your Kubernetes manifest, test locally, write your Helm chart, test locally, and then migrate to the cloud. So that's sort of the steps that you've been following. Now that your app is running in the cloud, what do you do for about observability? That's a big deal. I know, and I'll talk about observability. How many of you are coming to Code Motion tomorrow? A few of you. Nobody? Yeah, that's all right. No, you got me here. So I'm giving a keynote tomorrow morning, and I'll talk about observability over there. But essentially, it's important that the system is observable. And what I mean by that is that given a set of inputs, I should be able to know exactly what the set of outputs are. But I have more observability in the system, that what is going on inside the system, the what and the why. I don't care about only the what, but I also care about the why, so that I can understand, in case things go wrong, I can figure out what might have happened and then take a remedial action which will improve that whole part of it so that it doesn't happen again. That's the observability part of it. Now think about when you're creating your microservices based architecture, you're using different programming languages. Okay, now if you were to incorporate your routing logic, your observability logic, your transportation logic, all of that into each microservice, what happens? It ends up being a framework explosion. You need to know that for Java, for Go, for Scala, for all of your languages. And tomorrow a new language comes in, then you bake that into, and your microservice also becomes bloated. So the approach that a lot of customers are taking, particularly in the containerized world, is, and that's where the concept of pod kicks in, is, oh, pod can have more than one container. And that's where they say you have a main application container, but you can inject a sidecar container. And that's where you can say this sidecar container is consistent across the board, all the microservices, language independent, framework independent, but this will do all of this routing logic for me. All of the traffic then does not go from application to application. The logic goes from application to the sidecar, and then the sidecar goes to the other sidecar, and which then goes to the application. So entire network traffic now is going through the sidecar containers. Well, what are the advantages of that? A lot. Because the network traffic is going through sidecar, you can actually define application can talk to which application at the application layer, at the sidecar layer. You can define things like, oh, I want to introduce 5% of that. I'm introducing a new version of the application. Now I want to be able to give only 5% of the traffic to this new version. That you cannot do in Kubernetes very easily. Now the scales in Kubernetes are crazy, because typically what you do is you would introduce a new version of the service and an old version is running, but it's very easily, because let's say if you have 5 replicas running for old service, 5% means really half a pod. There is no such thing as half a pod. So at least you will have 10% of the service running, because if 5 pods are running, rather 5% means quarter pod. Think about that way, because if there are 5 pods running, each pod is 20% of the service. So you can't really introduce 5% of the traffic in there. And that's where things like sidecar comes in, because all the traffic is going through network through sidecar. Then you can exactly control that. How do you do my A/B testing, my canary testing? All of that can be done using sidecar. Okay. So now, what are your choices around sidecar? Well, Envoy is a very popular sidecar, and this was created by Lyft, and it is known to work at a very huge scale. And by very huge scale, I mean is 10 million concurrent requests can be handled by Envoy, across a wide range of containers, essentially. Okay, so that can be done very easily. Now, think about in terms of your microservices. If you have these microservices running, and each microservice essentially has a Envoy sidecar. That's your data plane. That's your Envoy data plane. You need something to manage that data plane, which is your Envoy control plane. Now, a popular option is Istio. Istio is a popular control plane option for Envoy. Um, Once again, I was meeting with a lot of customers last week in India, and pretty much across the board, they were all saying that Istio is causing problems to them, particularly at scale. It's good to begin with, kind of gives you a good feeling. The set of features is really good in terms of A/B testing, canary testing, mutual TLS, all that. Those are very excellent features. It's yet to prove at scale. And particularly Istio is very, very tied to Kubernetes. So maybe this is relevant if you're only doing Kubernetes today, but that never happens. There's a new like in a year or two, and we're all drifting towards it. Kubernetes was not a thing about 4 years ago. You know, Docker was the hottest thing. Docker is not the hottest thing anymore. So I think to keep in mind that let's not get emotionally attached to a technology. So AWS introduced something called as AWS App Mesh, which gives you that managed control plane. Istio, again, you have to manage yourself, but AWS provides a managed control plane for Envoy, and data plane, of course, lives in your account. And it works not just with bring your own Kubernetes, but it also works with ECS, which is our managed container service, and bring your own Kubernetes on EC2, or raw microservices running on EC2 as well. So there are a lot of ways by which this thing runs very well. I won't dig into the details for App Mesh. You can read the entire thing over here. The process is a bit verbose right now, and we are working on simplifying the instructions. But the entire set of steps on how you can get App Mesh running with EKS is explained over here. Okay. Now that's that part of it. So I won't dig into the details here. But the key part for you to understand is it has features like traffic shifting. And what does traffic shifting mean? What it means is that now I'm introducing a new version of an API or my app, give only 5% of the traffic to this, whereas 95% over here. And I can do health checks that if this 5% is looking good, then upscale it and slowly downscale this one. So you can do those kind of rules that makes your app, be self-sustaining. And then you can also say, hey, by the way, if the metrics or the threshold for these are not met, fire it away. Terminate this one and keep everything on the old one itself. So those are the kind of rules that you can set up, and there are examples over here which talks about it. And similarly on Istio as well, kind of talks about how you can download it, how you can install it. It's a lot more detailed. So Istio definitely has more set of features right now because it has been in the market for much longer. So it definitely has a lot more set of features. But again, depending upon the scale that you're running at, I've definitely seen concerns around scalability from a lot of customers. So this is traffic splitting. So what happens here is I'm calling it 10 times, and on average you'll see 75% to 25% split. You can do canary deployment. Let me actually show you one of the Istio files which shows exactly how you can do this. If I go to manifest, for example, and I go to Istio, and I can say app rules 75-25. Okay. So what I do in Istio is I say create a virtual service, and it's accessing the host greeting, which I'm going to define later. But there are two routes. First is destination host greeting, but subset is greeting hello, and the weight is 7. And then I have another version of service deployed, which instead of hello says howdy. Okay. So, but they have different labels. So this is subset greeting howdy, and weight is 25. Now this is my virtual service, but now I'm defining my greeting destinations. Okay, destination rule, which is again a Istio concept. And this greeting hello and greeting howdy are defined, They literally are defined by the labels that are on the service. Okay, so think about, I have deployed two services, one with greeting hello label, the other one with greeting howdy label. They map to the destination rules over here, and these destination rules are then referred in my virtual service, and that's how I'm splitting up 75-25. And I just picked up a random 75-25, but you can do this 90-10, 95-5, whatever works for you. The total needs to be 100. You can do connect as well. Yeah. Second. The question is, can you automate that? Yes, you can. Essentially, what you do is you build automation in terms of health. That okay, I've done this 75-25 rule to begin with, and then you can say if the health alerts are passed, like CloudWatch metrics looking good, then instead of 75-25, make that make 25 as 40 and 75 as 60. So there are rules by which you can specify all of that. No, this is Istio. Oh, absolutely. These are all the constructs for Istio, so which is basically in the mesh. Yeah, yeah, and that's the common way customers use it actually. Yeah. So that's not the concept that you will use though. Now that is a more of a Kubernetes concept. Think about, now Kubernetes is a node-centric architecture, right? It has this concept of worker nodes on which the containers are running. Your question is, oh, I'm getting more workload, I need to spin up more containers. But the number of containers that you can spin up is limited by the number of worker nodes you have. So you need two concepts to manage that. One is the concept called as cluster autoscaler, which will say, oh, by the way, each node can have up to 10 pods, whatever, just picking a random number. And I have got 5 worker nodes here, so that means I can do 50 nodes, 50 pods. For the 51st pod to be scheduled, it will say, oh, unschedulable. So what cluster autoscaler says is, anytime a pod is unschedulable, it realizes that and it scales your cluster. And you can set up the metrics in the cluster autoscaler on how to scale the cluster. That's one part of it. The second concept that you need is called as a HPA, or horizontal pod autoscaler, which looks at the metrics and the threshold, which could be, by the way, custom app metrics, JMX metrics, all it cares, Prometheus metrics. So it can look at those metrics, and then it says, oh, by the way, this Prometheus metrics is saying the latency of your application is more than 400 milliseconds, fire up a new pod. So horizontal pod autoscaler. So together, cluster autoscaler and horizontal pod autoscaler will work hand in hand to grow your cluster and make sure a sufficient number of pods are available to serve the request. So let's come to the last part of it, where how do you set up a deployment pipeline? That's an important part. Never send human for a job of a machine. That's where I've seen tools like Scaffold. And Scaffold is something that you install on your local machine. It's very powerful because it connects well with the Kubernetes ecosystem. What's happening is you have an IntelliJ up and running, you build your Java application, and you can specify your Scaffold configuration file, which refers to the Docker file. And what happens is, it's running sort of a deployment pipeline in the backend. Anytime you make a save to your Java file, it has the knowledge, it'll pick up, package your fat jar, use the standard Docker file, package your Docker image, update your Kubernetes manifest, and deploy the manifest. So imagine with a single save file, if you have, it can actually automatically update your manifest and run the updated app in your Kubernetes cluster as well. So it's very good for interactive debugging and testing and all those kind of things. So that's good, that's cool. That definitely helps you boost your productivity in the local development environment, but you need something more for production environment, and that's are available. I've seen some comments about Jenkins X, although it's very hard to use. I've seen it sometimes. Jenkins is basically a version of Jenkins that is written targeted towards Kubernetes. The tool is okay, but it needs work to have a slicker experience. It works very well if you create the app using Jenkins X, but for an existing app, it's a bit tricky to use. A lot of our customers use Code Pipeline, and again, these are fully managed services from AWS. If you want to use them, I have a template here on this repo, which gives you end-to-end pipeline which pulls the code from GitHub. With every good push, it fires. Something else that I should add to this one also is things like Circle CI or CodeFresh. All of these tools, which are managed services or partly managed services by other partners of AWS, they also offer similar services as well. Okay, so that's sort of lay of the land that you need to be aware of as you are a Java developer and bringing your journey that I want to go on Kubernetesizing my Java application. So first step, think about what build tool you're going to use to Dockerize your application: Maven, JIB, Dockerfile, multi-stage Dockerfile, whatever that is. Think about then how do you write your Kubernetes manifest. Think about writing your Helm charts. Then think about how will you test the Helm chart on your local machine using Docker Desktop or Minikube or Kubernetes in desktop, whatever, wide variety of ways. Then think about where you're going to run your Kubernetes cluster. AWS, Amazon EKS, whatever, we don't care. Run it, switch the context, migrate your app to the cloud. Then think about a service mesh. It's very early in the service mesh cycle. In general, anything that I do, I always think about it. Is it a golden hammer? Am I being astonished by the new toy? What problem is it solving? So don't adopt Kubernetes or service mesh or any technology, as a matter of fact, unless it's solving a business problem. As a matter of fact, don't adopt microservices if they're not solving your problem. I've seen a lot of customers phased by the everybody's going microservices. I'm going to do microservices as well. What is the problem? Always think about it. I as much as I like it, I've written courses and books about it, but I'm not emotionally attached to it. My first question in customer discussion is always, what is the problem that you're trying to solve? Is it bringing agility? Is it bringing, is it giving you faster time to market, time to value? What is it that the problem that you're trying to solve exactly? And last week when I was talking to customers, particularly this is fresh, all of them, they said, which is funny, it says, it helps in boosting morale of employees. They feel happy that Kubernetes is on their resume, and it makes them more marketable. We had this discussion in one of the open source forums, and what we often forget is that open source brings resume portability. The fact that you work on as a Linux SRE, whatever, Kubernetes SRE, there was a Reddit thread that I was reading where this guy says, I worked in a startup company as a Kubernetes SRE, and now I'm getting a compensation for $350,000. And it's pretty cool. He's pretty excited jumping around, because that experience can bring a lot of value. So don't get me wrong. I'm not pushing one way or the other. I'm giving you data points. You make your call. Take the red pill or the blue pill. Upon you. Any questions? Any more questions, actually? Yeah. I want to deploy my application using Helm. It basically uses the underlying kube control. Because kube control is essentially a way by which you can figure out which configuration, which cluster you're talking to. Under the scenes, still uses kube control to deploy the application to the cluster. Because at the end of the day, all of these templates that I have, what Helm chart provides? Helm chart provides you a single place where you can define all your applications together using a standard directory structure. Right? So that's why under the scenes is still using, it basically provides a pre-processing layer by which it uses that templating language to create your deployment specs, and then uses kubectl to point, oh, what cluster is being configured to. So for example, if I have a Helm CLI installed on my machine, and I could say Helm install app, and my kubectl is pointing to my local cluster, Helm will install there. So think about the sequence. I say kubectl config point to the local cluster. I say Helm install app. It installs the local cluster. Then the next step, third step I do is kubectl config, change the context to the cluster on the recommendation is, in that sense, if you were to take that as a recommendation, create your manifest, get a feel for what your manifest look like, and then you start bringing out the commonality in them. Then you go to the Helm chart, and then you say, now I'm going to go with the Helm chart. Something else that is being worked on in the industry is called a CNAB, or Cloud Native Application Bundle. That's a new spec that they're building, which is probably going to be more on the standards route, and there are discussions happening around that part of it. Very early in the cycle, Helm is sort of the de facto way I've seen customers deploying application. Something else that you also want to know is, with Helm 2, which is sort of the current version in production, there is a client component and a server component. Because end of the day, you say, hey, Helm install this, and the server component of Helm is called as Tiller. So Tiller is sitting over here, Helm CLI is sitting over here. Helm CLI generates your templates, and it says, hey, go ahead and deploy this. And the Tiller here says, oh, I got it. I'm going to take the deployment over here locally. So that's sort of the Helm 2 architecture. In Helm 3, they've gone away with the Tiller part of it, because Tiller is a security concern for a lot of customers, that because it gives you unaccess to admin access to your Kubernetes cluster. So something that you need to be aware of what's happening in the Kubernetes land. Helm 3, I believe, is in beta or maybe close to GA.
No.
Sorry.
No.
Thank you. Is there any worthy advantage on using Kubernetes for local development compared to using, let's say, Docker Compose, which is fairly easier?
Yeah. So I tend to keep my dev, test, prod, and staging, all the environments exactly identical. I've seen some customers where they want to use Docker Compose for local testing. Easy, I get it, completely get it. I'm a Docker captain, so I've used it and I've written a lot about it as well. But the challenge with me is, if you're doing your local development with Docker Compose, you will have to kind of figure out at what point do you tip over to the Kubernetes side, because ultimately that's what is going in production. So personally speaking, I would not, if I'm going the Docker route, if I'm going the Docker Compose route all the way to production, I would happily continue. But if I know my end goal is over there, I would not waste time in Docker Compose. And I've had conversations with customers. We started, that's why we are here. I said, but that doesn't make sense. And they said, yeah, I agree, but keep it as close, because you want to minimize the variability as much as you can.
Regarding what you already mentioned about Istio, what exactly the issues that you already figured out from your customer? So I didn't get that.
So I can't share a lot more details, but typically it ends up failing at a scale. If you're running at like hundreds and thousands of containers, that's where Istio kind of starts behaving. For example, if you think about the Istio control plane, right, and all these hundreds and thousands of containers are running over here, that's where Istio is not able to enforce the policies that which app should be able to talk to which app. The canaries and all kind of start becoming more unreliable.
Okay.
Because you expect that something that is working at a smaller scale, if that is the commitment that the project is making, it should continue to work at the scale. So those are some of the challenges. Just search for Istio challenges, you will find out.
Okay. And Linkerd, for example, not an alternative?
No, Linkerd absolutely works as well. Linkerd is actually known to work at a lot bigger scale.
So it could be a recommendation.
It could very much be. It's just that I haven't played with Linkerd and Kubernetes connection particularly. Yeah. And Linkerd, by the way, is a CNCF project.
Yes.
Yeah. Right, I guess people are hungry, and I think the pizza is here right on time. All right. Well, my Twitter messages are open. So you can always, my DMs are always open. So you can always send me the messages if you have any questions, clarifications.
Nada, tenemos ahí unas pizzas, cortesía de Liferay. Tienen que llegar más, o sea, nos usaron y hasta la próxima.
Claro, que hay poco ambiente.